Today we're going to solve exponential and logarithmic equations and inequalities if we get to them. So again, some of the things we're going to say, yeah. So first slide, solve using common bases. We did this yesterday, right? Each side goes down to a base. What's 8 and 4? Common base is what? 2. So 8 is 2 to the third. 4 is 2 to the second. Our bases are the same, therefore our exponents are also equal. Done. We did that yesterday. Right? We can do that? Okay. Moving on. That's just kind of review. Now it's those kind of on steroids. Same thing. Both of these have a same base. What's 9? 3 to the second. We have an x. So both sides have base 3. So we set our exponents equal. And x would equal 1. Not hard, right? Good. This middle guy. How do I write 125 as base? It's going to be base 5, right? It's 5 to what power? Third. 27 is 3 to the power of 3. Since they're both powers of 3, I can write it like this. So we're getting closer to what the left side looks like. But we have to flip it. So if I write the reciprocal of this base, what happens to the exponent? It changes to a negative. So now my bases are the same. So x equals negative 3. Does that kind of make sense? All right, the last one is the most challenging one. So the left side is pretty basic. It's 3 to the x. 9 is 3 to the second power. There's more than one term here in our exponent, so we have to put them in parentheses. Times 27 is 3 to the third, 1 minus 3x. Now, what do you do when you multiply, bless you, like bases? You add the exponents, right? So 3, when we add these exponents, we're going to have a negative 7x plus 1. Our bases are the same. So our exponents are the same, and you just solve that linear equation. So some of them can be a little bit more complicated than the basic one that we did on the previous slide. I mean, we were preparing you for the test of all tests, but the test really isn't as hard as some of these questions that we're giving you. Just to set your mind at ease. You're going to be over-prepared. All right? We good? All right. Let's just do one of these to save some time. We want to get to solve the exponent. The exponent is is where the variable is, so we have to eventually use logs. But first we have to isolate the base. So we need to get the 2x minus 3 to itself by itself. So what do we do with the 5? Divide. And again, I'm not going to pick my calculator up till the very, very end. We want to be able to bring that exponent down in front, so we have to take the log of both sides. That lets me take this exponent and drop it down in front. So, what do we do now? How do I get the x by itself? What do you have to get rid of first?
Divide by the natural.
There you go. So we're going to divide. And then we just add 3. Now you pick up your calculator because your x is by itself. All right, so make sure you can put these in right. Make sure your answer matches my answer, and we are rounding to 4 decimal points. We can do that. That's not too crazy. Let's try. We ready? We want to do this one or this one? Let's do this one. This one's more complicated than the other one, so it's better. All right, we have exponents on both sides. So we have to take the natural log again of both sides. So here's the deal. You cannot drop down the exponent. You can't take this guy and put him down in front. You have to have the log of a single base with an exponent to use that rule. So somehow, I have to split these two up so that this guy is with his own individual log. So how can I split those up? You add the 2 logs. So we're going to do the log of 2, plus the log of 3 for the x minus 1. You can only use that power property if you have a 1 base. So now I can take these powers and put them down in front. This is a long, involved question, or not. So, we have to get this x out of the parenthesis without solving because we have 2 x's. So we're going to have to distribute. So we're going to have the natural log of 2 plus x times the natural log of 3 minus the natural log of 3 equals, and on this side, same thing. The x's have to be gotten out of the parentheses.
Why did you distribute on this problem and not the last one?
Okay, the last problem, we only had 1 x. So I could just divide by that log and then get rid of the number. Here we have 2 x's, so we have to be able to distribute and then get them together. Now, we have 2 x terms. Does everyone see them? They have to be together on one side, and all the other stuff has to be on the other side. So I'm going to take this term, and if I put him on the other side, what's going to happen? He has to become what? negative. We are going to subtract him to this side. All right? This term and this term have to move to the right side. So on the right side, I had left the natural log of 5. If I move natural log of 2, he becomes a minus. If I move the minus natural log of 3, he becomes a plus. So you can do that in 2 steps or whatever, but that's what we're doing. We're taking everything that's green and moving it to the opposite side. All right? We still don't have, Max? We want everything with an X to be on one side and everything that doesn't have an X to be on the other side. All right. I need an X, just one X. How do I make 2 X's become 1 X? And we did this earlier this year, whether you guys remember or not. It's something you guys don't like, so you don't look for it. Starts with an F. Factoring. Do you see that there's an X in each term? So I can take an X out, can't I? If I factor an X out front, now I have a single X. And then our very, very last step would just be to divide by this entire thing. Please pick your calculators up and make sure you can do this correctly. Understand, the numerator needs to be put in parentheses, the denominator needs to be put in parentheses. Okay, so I get negative 3.9444. Okay, everyone get that? Anyone not get it? We're all good? Nobody made a mistake with that in the calculator? Impressed. All right. What's the interest rate required to triple your investment of P dollars in 5 years if it's compounded quarterly? So let's remember the formula for compounded something other than continuous. Okay? And if I say quarterly, the N stands for a 4, right? So what interest rate is it required to triple your investment? That means when I divide the P over here, I start with a 3. Okay? So this one's not too bad. How do I get rid of the 20th power on one side? We don't have to do logs here because the power is not our variable. How do I get rid of a power? If it was a square, I would take a square root, right? I can take the 20th root, or easier just to raise it to the 1 over 20th power. That gets rid of my power. And I'm still working to get the r by itself. What's the next thing to move? Subtract 1. Still not touching my calculator. Last step, I want to get the r by itself. Multiplied by 4. So that would be the entire side gets multiplied by 4. All right, so this is just solving. Pretty hefty interest rate here. 22.6%. Okay. Does that make sense? Plug in what you know and look at it. If your variable is not an exponent, you will not have to do logs. You just have to move things around. Okay. But again, do not touch the calculator till the very end, so you don't round. Okay, now we're going to solve log equations, and they look more complicated than they are. So pick which one you want to do, right or left. Right side? That's good. In order, if you have a single log, I just have one log by itself. Get it by itself. Get it alone on one side. So we're going to subtract 4 and divide by 3. So my log is by itself. How do you get rid of the word log? You have to get the x. You can't divide by the word log. How can I rewrite that without a log? Exponential. Yep. So 2 to what power? Or I'm sorry, 2 to the negative 1 equals x. So I'm going to write the reciprocal to make that a positive 1. And you're done. So you're going to isolate the log term with basic algebra, then rewrite it exponentially. Do we need to do the other example? I'm going to do it while you guys are finishing writing that one down. Okay, remember what base you are in. On Math Excel, they may ask you to write the exact value. This is exact. And when you put it in your calculator, then it becomes an approximation. So remember, E is irrational. All right, next. If you have multiple logs, they're everywhere, right? Every term is a log. I wish there was a way we could combine these so it's simple. How could I combine those? Log base 4, x squared plus x, right? We're going to multiply those together. Let's go ahead and just show that step real quick. Right? On the other side, I can also combine them using multiplication. So we're getting simpler. If you have the same log base on both sides, you can cancel them out. And then we can distribute. So x squared plus x is going to equal 6x minus 6. And then solve it. We all know how to solve it. Bring everything to one side. And try to factor. Please try to factor before you do the quadratic formula. So we get two answers. X equals 3 and x equals 2. Because log functions are restricted on the domain, you have to check your answers. They both work, but if you go to put the answer in, and I say the log of, and this ends up being a negative when you plug it in, you can't use it. You can't take the log of 0 or below. Okay, so when you plug your answers in, the number after the word log has to be positive. All right? Are we okay? You want to do the next one? We're all good? I'll just do it real quick. So I get a -2 and a -3. If I put either of those in this function, I'm taking the natural log of a negative number. So you would say there was no solution. Okay, so you have to check your answers. You have to check your answers. Okay? All right. Moving on. do you think? Can I combine the left side into a single log? They're the same base, so we can combine the left side. And since now I only have one log, I can rewrite it exponentially. And you have, again, a quadratic. All right, so if you have more than one log on one side, combine them and factor. So your x equals 5 and 2. Remember, you have to check them. If I put the 5 in, paint it with the log of 2 here, that's okay. If I put the 5 in, log of 1. If I put the 2 in, you see I'm going to get the log of negative 1 here? So 2 is extraneous. And you would only put 5 down for your answer blank. You understand how we're checking? Do we need to do the second example, or are you okay? Okay. All right, inequalities. Thompson's power? Oh my God, we're doing that. All right, inequalities. Same thing, we want to get the base by itself, because we're going to have to do logs. So we have 5 times 0.7 to the x is less than 15. And then we're going to have 0.7 to the x is less than 3. And then we're going to take the natural log of both sides, or the common log. Again, that's your choice. So in order to drop the exponent down, you have to take the log of both sides. And then you are going to divide by the natural log of 0.7. Now, think about it for a second. The only time this symbol will flip around is if you divide by a negative. If you take the log of a number less than 1, it is negative. You have to remember that. So I am actually dividing by a negative number here. So when I divide by that, I'm flipping the symbol. So if you're dividing by a log of something less than 1, it's actually a negative number. Okay. So keep that in mind. Try this guy here. Is the natural log of 5 positive or negative? Positive. So when I divide by it, my symbol stays the same. It doesn't reverse. All right. Not too bad. One more slide. Now, these are weird. First of all, you need to figure out what the domain is. So remember, the domain of the normal guy, anything after the word log has to be greater than or equal to 0, has to be positive. So we're going to go to the side and say my domain is 2x minus 5 is greater than 0. So that means x has to be greater than 5 over 2. So in the back of my head, that's my domain. because inequalities are going to give me an interval. With these, you have to take the base, whatever base it is, and raise it to both sides. I know this is going to be weird. All right. Because this is base 10 here, this cancels, and you have 2x minus 5 is less than or equal to 10. If you just write it exponentially, which side does it go on? That's the problem, the exponential. Flips its own. You write it, okay? And then you're just solving. So 2x is less than or equal to 5. X is less than or equal to 5 over 2.
Wait,
15, thank you. I said something's going wrong because we're getting the same thing as the domain. Good job. You guys are so good. All right. So think of our number line. X is less than this number, but it's greater than 5 over 2. So our interval is going to be 5 over 2 up to and including 15 over 2 because it was an or equals 2 equation. Does that make sense? Let's do the other one. So we're going to start, the base is e, so it's going to be e raised to the natural log of 1 minus 3x is greater than e to the second power. So these guys cancel and the 1 minus 3x drops to a regular. And I'm dividing by a -3, so what happens to my symbol? It flips. So using your handy-dandy calculator. Bless you. We got to figure out our domain still. We didn't do that at the beginning. So our domain is 1 minus 3x has to be greater than or equal to 0. So negative 3x is greater than or equal to -1. X is less than 1/3. So if x is less than 1/3 and our answer is less than -2.13, it's already less than 1/3, so it's already within the domain, so we're okay. Okay? We're both less than, so you're just going to go from the answer. So if you look at the number line, one-third's here, -2.13 is here. They're saying the answer is below -2.13. As long as it's already below the 1/3, we're okay. Okay. You guys rock. First, let's go back and see if there's anything else we want to cover. Since we have time.
No.
Just double check. I got other people watching this.
We got it.
Guys, we're done.
Well,
Okay.
it is in the.
All right, so tomorrow you have a Math Excel workday. You will get your take-home quiz at the end of the period tomorrow. You have a math or a take-home quiz workday on Monday. Tuesday we'll start reviewing for your tests. All right.